Hi, software engineers. Time to continue our story about how modern web applications came to be. I guess I could tell a story here at the amphitheater, but maybe there's something a little bit better. There we go. That's what I'm talking about. So, let's get cozy by the fire, get a cup of your favorite tea or coffee. Let's talk about modern web applications. So, modern web applications are not just about what you see on the browser. There's a bunch of stuff going on in the background on the server side that actually drives what your application is doing. So we want to build good web applications, and we're talking about that in the context of using MVC frameworks. So in order to get to that point, we need to start with, well, how did the web come to be? So the evolution of the web technologies has happened pretty rapidly over the past 20 years or so. And so we need to kind of figure out how it started so that we understand how we've gotten now to the point where we're exposing functionality and building our application by putting these large components together. In the long, long ago, in the way back time, the web was just a bunch of file servers. So the idea was basically that you could take a computer and open a port, which, you know, is kind of like changing the channel if you're talking about television. Port 80 is where most HTTP web traffic travels. I mean, you can have alternate ports, but 80 is kind of the main one. So you would open a port and your browser would say, hey, computer, I'm really interested in your index.html file. And the server, the piece of software server that's running on the server, the piece of hardware server, yeah, that's nice and confusing, was basically just a simple file retrieval application. So the original version of Apache or IIS or any of those just said, oh, cool, I have mounted /var/dub or some folder on this computer, and you want index.html? Cool. So it goes and finds the index.html file, chops it up into itty bitty bits, and shoves each bit down the internet. If you want more details on that, go take networking, but that's the basic idea, okay? So it would pick up the HTML index.html file or whatever file is being requested, chop it up, send it to the client, and the web browser would put it back together. And that was all well, fine, and good if the information never needed to change. If it was just basically looking at stuff on the digital equivalent of a tack board, and you just wanted to go from one page to the next. This was what HTML was at the time. But we wanted to be able to do more interesting things than that. We wanted the web page to look different or do different things or give different information based upon a change in a data model. So for instance, you're trying to sell something, but you have 10 things in stock. Well, as things are sold, you want it to show that now there's 9, 8, 7. You want it to actually tick downward. You also want it maybe to dynamically choose a price based upon a sale or something like that. Or maybe you wanted to make a message board where people could add information. So now we've started adding the capability for websites to be dynamically generated. So now when your web browser talks to a web server and says, hey, can I get the file at the root of this directory? Now that file might not be index.html, it might be index.php. We'll use PHP as an example here because it's easier. So when Apache sees a .php file, it goes, whoa, this ain't HTML. This is something I'm supposed to run. And so Apache has built into it, says, if you see something called PHP, hand it to the command line interpreter, the CLI first, and let it run the code. And the output of that will be HTML, and that's what you'll send back. So when you're talking about a dynamic web page, there often isn't a .html file somewhere on a web server that you're grabbing. It's actually the build of a website, the build of that web page. What you're seeing in Django, for instance, when you create a URL link in your urls.py file, and that loads a view, and that view pulls a template, that's exactly what's happening. You're dynamically building that page. Now, this is much more advanced than my simple example here, but this is how it got started. We wanted cool websites. Now, this was great. People loved this. People wanted these awesome dynamic websites, but then more and more people wanted to use it. So we needed to figure out a way that we could add more servers on the backside. So how did we then know what one person was doing? So as things became more and more complex, more and more users were hitting it, we needed more bandwidth, but we needed to be able to keep up with okay, was this user talking to this particular server? And if now they're talking to a different server, how does that server know what was going on? How does it know what the state was? How does it know what web page it was on? So we've tried all sorts of things for doing this. We tried Java beans. We've tried other sorts of static implementations. I mean, this is exactly what we're talking about. If you remember the diagram from the last video, where we had the mobile and the laptop connecting to this bank of servers, how do we know which server we're talking to? How does that help us out? So the idea of state became a huge problem. If we were trying to manage what a user was doing when they moved from website to website, we had to know the context in which it happened. And so Java Beans was one way to do this, like I mentioned. It was basically a state object that could be passed between servers. Well, that was really complex and really resource intensive, and it was really, tough to manage. Now you might think, Sheriff, we have solved this problem. This is not something that we run into. Oh, really? Have you looked at sys recently? And I mean this in the nicest kind way to all of my friends over in ITS and support, but there's some aspects of sys that kind of break the internet. Have you ever hit the back button in sys? What does that do? Does it like that? Have you ever tried to open sys in multiple windows? Have you ever tried to click on anything that requires loading data? Yeah, it has that little spinny thing on it. This is odd. This is not how the internet is designed to work. The internet is meant to be asynchronous. Here's an example of how state is a problem in sys. I wanted to show you this to you live, but I figured out OBS doesn't grab this properly, so we'll have to use a screenshot. So if I was to roll over I can actually use a mouse here. It will grab this. If I was to roll over this icon right here, this is the JavaScript that pops up. JavaScript submit action win 0 document class roster. Actually, it's this one right here. $1. What do you think it is if I roll over this one? $0, $2. You get the idea. Yeah, those aren't real links. Those are function calls. And that's not necessarily a bad thing, but a function call only works if you know what state is happening. So if you look at this function call, it's having to pass some notion of state over, because how does it know what class roster $1 is or $0 is? It has to know the page it's coming from. So that's why state is such an issue. The internet doesn't work very well with the idea of normal desktop applications. A normal desktop application works because you can store stuff in memory locally and it knows, okay, you were on this page, I know kind of how things were happening. But if you are building web applications where you could theoretically talk to one server one time, another server another time, another server another time, because you've had to expand your bandwidth to handle as much traffic as you're getting, state all of a sudden becomes a huge problem. Here's another thing to think about. If you're on a mobile device and you go out of service for a bit and then you come back, if we're talking about the other way of managing state through memory objects, has gone stale now. And that server isn't going to remember who you are. So we need another way of making the web work, of making our applications work the way the web is meant to work, which is asynchronously. I send a request and I step back and I wait for the server to send a response back to me. If we fully embrace the asynchronous nature of the internet, then we can build really cool applications that allow us to send our requests to any server as long as we can tell it the state in which we are coming. So we need to find a way to embed our state in the action. This is what representation state transfer is. This is REST. REST is a way of solving this problem. Good modern web applications use REST as an architectural design pattern for solving things. REST has 5 aspects that we care about, and we're going to go through each of those aspects to explain how it makes your application work better. And the first is statelessness. The idea of statelessness is the web server does not store any memory about a user. The web server This does not mean that the client, remember client server, the client is allowed to store that. Matter of fact, the client is responsible for storing it. And also the database is allowed to store it. So whenever I make a request from my client, it needs to contain within it all the information it needs in order to be processed by any server. So the way this looks is, in this example, if I add a database server right here, all of these are allowed to talk to that database server. That is fine, because a database server knows how to handle multiple requests all at the same time. As a matter of fact, you could actually expand this to multiple DB servers if you wanted to. That's totally fine, because databases can do their own thing too. But if my request comes in and goes to this server and that database, or it comes in and now goes to this server and the database, or this server, as long as there's a data model that's living right here, then it doesn't matter. It doesn't matter. This is why a good web application, not again hurting on sys, but if I opened the same application here as here, if they are both sending my login credentials plus whatever context I need, then that is bookmarkable. It is something that I can run it in multiple browsers. I can hit the back button. It all goes back to working the way the internet kind of is supposed to work, which is kind of what we want. So every bit of information has to be in that request. The second aspect is idempotency. This is a tough one to say. Practice this. This has gotten awkward sometimes in office hours, but since we're having digital office hours, maybe it's not as awkward. So idempotency means identical requests give identical results. So if in this example, the mobile app and the laptop sent the same request to the servers, even if they hit different servers, since they're talking to the same data model on the other end, I should get the same response, unless for some reason the data has changed. But this basically says that it's not contingent on some sort of data being stored on the client side, or excuse me, on the server side. So a nice thing about this is it allows for caching. If you can cache images and some commonly hit web pages, then your web application is going to just go faster. If your web server can respond, that hasn't changed, then all the better. The next is addressable resources. Everything has a place. Every place has a thing. Okay? Everything has a place. Every place has a thing. So you see this all the time with your Django apps, right? You go to your Django app and you go to URL / the name of a view / some action. That's not something you've made, not a folder or anything like that. That's like a function call. Here's another example. Let's go to Amazon. Here we are on Amazon. Amazon's a wonderful, exciting place. I would like to buy some things. Sure. I am interested in Mario 3D All-Stars because I would like more than one copy of this. And let's go to this one. Let's actually delete all of this right here. That's superfluous. Okay. I want you to think for a moment. Do you believe that there is someone whose job at Amazon is, oh, Nintendo is coming out with a new game. I need to go to our main Amazon web server and make a folder called Super Mario 3D All-Stars Nintendo Switch DP this number, so that when intrepid people like McBurney and Sheriff go to buy this game, they have a folder to go to. Think for a second. So one, does Bezos have the money to do this? Yes, he does. But a better question is that a good way to write a web application? Absolutely not. That's silly. What the application actually is doing is this part right here is kind of just a throwaway so that when you bookmark it, it actually goes where you want it to go. Still loads. Because what it's looking for here is actually this product, look for this product. That's the product identifier. That's where it needs to go. That's the thing it's actually trying to load. The previous URL, when I bookmark this now, it says amazon.com/Super Mario 3D All-Stars. That is there solely So it looks nice in the title bar. It looks nice when I bookmark it. And when I look at just a link I've copied, I don't have to remember what it is because it's in there. It's ignored. The RESTful architecture pulls this out, pulls this B08 jazz out, and that's what it uses in order to actually load the piece of information. So everything has its place, and every place has a thing. Model View Controller is really good at this because all of your resources, all of your models could be interpreted by the controller. Well-defined operations. So the easy way of thinking about this one is you can't do streaming, which makes sense because streaming basically removes statelessness to some degree. The idea is you're using post, put, get, and delete, which are standard URL commands. The ones you really need to know the difference of, a post means that when you submit to a website, the information is embedded in the packets. So you've probably gone to a website at some point and hit the back button and says, oh, we're going to have to resubmit the form in order to re-go to this page, yada, yada, yada. That means the information was stored in a post. If the information is stored in the get, then it's in the URL bar, and that's where you see things like Google searches. Anything where you want to be able to bookmark something needs to be in a get, not in a post. From your perspective, from Django, you can read the variables however you want to. That's not a problem. But anything you put in the get, which is the URL bar, anything you put in the get, is not encrypted. So make sure you're not putting like username and passwords there. That would be super bad. But that's what we mean by well-defined. And then finally, structured data. So whenever you get a response, it's going to be formatted in some way. It could be HTML, it could be XML, it could be JSON, but basically it has to be parsable and understandable. So we have statelessness, idempotency, addressable resources, well-defined operations, and structured data. Those are the 5 aspects of REST. So whenever you're looking at a RESTful architecture, you should find some degree of those things. Here's an example. So let's talk about this. If we were starting from scratch to build a shopping cart, and we knew nothing about REST, maybe we're using something like Java, what might it look like? Well, let's say we wanted to have like an array list of things that's the shopping cart. Okay, that kind of makes sense if you're building something just from scratch. But now you're talking to a different server. So now we need to be able to move that array list from server to server. So maybe I need some sort of global array list manager. And then I need to then generate an order somehow from that array list through a different application. So it starts to break down kind of quickly if you want to have any sort of scalability on the internet. If everyone is using array lists, how much memory is that going to take up? How do you manage server balancing? If you move to another device, if you were storing that array list somehow in memory on the client and you move to another device, you lose all that. So all of these things we don't want. I mean, you've probably done some shopping on some website, put something in a shopping cart, and gone to another device and seen that the item is still there, and that makes you very happy. We tend to not want to break things like that. REST is the obvious answer. So, if we were to do this, we would have the state would be managed in a database, which is allowed. It's just not, you can't store it on the server. Okay, DBs are fast enough to handle that. That's not a problem. This will allow you to connect from multiple machines with the same login credentials. You can use any of the web application servers that are available, so load balancing is available. And then every time you make a request, you just pass some token. It could be your login credentials, it could be a cookie that shows you've logged in, it could be any sort of thing that says you have permission to see this information. Then the controller loads your data from the model, which it doesn't care what the database is. It's just asking the model for your information, and it builds the website as you go. So the client says, show me the products. So the server says, okay, sure, here's all the products. Client says, I want to buy 2 of this. And it can point specifically to the item, put it in the basket, here's my information, and it stores that in the database that says you now have these. I could go to another client, I could wait years, assuming the website's still there, come back, then remove one, and then go to checkout. This is what REST gives us. It makes the web work like we want it to work. It takes advantage of the asynchronous nature of the web, as opposed to trying to force us into the the mental model of a desktop application that you hit a button and data is managed through local variables. Not to say that's bad, it's just not right for the web. And it's also not right for mobile in many cases. Unless the model is changed, if I make the same request from my mobile device or my laptop, I'm going to get the same thing back from the shopping cart, which is exactly what I want. Notice that I was using URLs to identify the resources. You don't have to do this, but this is just in this worked example that showed that I could access it as an object in the system. Well-defined operations, we're just going to assume that this was using HTTP and that this was all good JSON stuff being passed back and forth. In many cases, the well-defined and structured, you just kind of get because you're making a web application, typically. So we care much more about statelessness and addressable and idempotency. So put this in the context of MVC now. We have a controller that manages the communication of our system. We have a model that describes data, and we have a view that indicates how to present that information. REST and MVC go together like peanut butter and chocolate, like bananas and American cheese. There's no way you caught that reference, but if you did, power to you. You don't always find them together, but if you're doing it right, you probably will, because if you have a good model, that gives you addressable resources. If you have a good model, that's going to be easily represented into a database to allow statelessness to happen. If you have a good controller, it's going to use well-defined operations. If your model view controller all works the way it should, it's going to be idempotent, and a good view and controller together are going to give back structured data. You could be exporting HTML or JSON or whatever with your template files, but it's always going to be structured. So most all MVC frameworks that you find will be RESTful. But a RESTful app doesn't necessarily have to be MVC, okay? And what most of you probably think of when you hear REST is you hear REST API. Well, we get that through an MVC framework because you have a URL. You've seen this in your Django app. So, herokuapp.com/users/ a number or some identifier. If instead of HTML, it was outputting JSON, and that was something that could be read by another application to allow me to log into that other application, we now have the ability to build an application by connecting these services together, which is where we're going to go next. A REST API allows us to do something called a service-oriented architecture, which is how we build modern web applications. So, that was quite the story. Hopefully this helps you understand how REST and MVC work together to build a better web. So, thanks for watching. I'll see you next time. Bye.